There we go. All right. So announcements-wise, before we actually get the class started, first thing, lab does meet this week. So if you have Monday afternoon lab, you need to go to lab today. You will need to bring a calculator and a pencil, not a test like in 108. It's going to be more of like some math skills that you need to get through this semester. So logs, natural logs, things like that. And about 2/3 of you guys have successfully logged on to Mastering Chemistry. If you have not figured out how to log on to Mastering Chemistry or are having trouble, it's all right. We have until Friday. The first homework is not due till Friday, so we got a few days to sort out any sort of technical issues you might be having. Good. All right, then let's talk about the syllabus. Let's see. There we go. So this is provided for you online. I don't print out paper copies, not because I love the environment, just because it's a lot of copying, and you guys all throw them away. So if you need it, it's on the course website. Everyone should have either a hard copy or an e-copy of the Principles of Mastering Chemistry and Molecular Approach, 2nd edition. Good, good. If you have the 1st edition, that's okay. Not much has changed between the 1st and 2nd edition. Just some of the end of chapter problems are in a slightly different order. Not a big deal. You will need a calculator that is non-graphing. So it should be something of the style like this, right? Where it has natural log, log, e, things like that. You can't use your phone as a calculator, and you can't share calculators. Fair enough. All right, everything else on the first page is just regular stuff, right? This is the second half of Chem 108, 109. Blah, blah, blah. This is predominantly a lecture-based course, so I'll do most of my work from up here. But there are some group work things that we do, more so this semester than last semester. This semester is a lot more math-intensive than last semester. We do a lot more calculations. The course webpage is the one I just showed you, this facultyweb.berry.edu. It has all the stuff you're going to need. Study groups. So after I finish the syllabus, I have a fancy questionnaire to fill out. One of the questions you can be thinking about in the meantime is you're going to be in a group of 3 to 4 students as a study group. This will be the group that you take your group quizzes with. It'll be the group that you do your group problems with. And it will be the group that if your group averages an 80% or above on an exam, everybody gets a bonus point on the test. So it's to encourage you to kind of lift up your friends and have them all do well, because that way everybody gets rewarded. That seems to work out pretty well. You obviously, we're going to have a study group from now to the first test. If you find that the study group you picked isn't working out either time-wise or relationship-wise, something, we'll change them after the first test. So you have that much time to kind of think about it. It's expected that you're going to come to class every day and you're going to be fully awake and looking at me during class. I do not take attendance, however. I'll take attendance today just to see who all's here. But in general, I don't take attendance. That doesn't mean I don't want you to be here. It's just, at this point, I'm hoping that you're so excited about chemistry that you can't imagine missing a class. I hear some giggles. I'm assuming that's excited giggles. Like, yeah, she's totally right on. Let's see, lab starts today. This is a new thing about lab. You must pass lab to pass the course. That seems silly, but there are enough people that try to skirt the rules, that fail lab but still try to pass the course, that now officially you have to pass the lab to pass the course. Not anyone here would be that person, but they are out there. We are going to have 3 regular exams and a standardized cumulative final. Yay! These are the days of the exam, about 1 every 4 to 5 weeks. If you know in advance you're going to have a conflict, the sooner we can work out an alternate time, the better it is. Final exam, Wednesday, May 4th, which is kind of like last semester, we took a standardized exam Same thing, but now it covers both semesters of chemistry. Here is the grade breakdown. Exams are worth 15% each. The final exam is slightly more because it is cumulative. Lab is 10%, the master in chemistry is 15%, and the quizzes are about 10%. And then the official breakdown of grades. Quizzes. At the end of some class periods, we will have a 10-point quiz. These quizzes you will know in advance. I'll let you know the class period before. They're not surprise quizzes. That we're going to have a quiz, and they're going to cover everything we've done up to that day. So you'll never have a quiz on material that we did that day. It'll be everything we've done up to that point. So I'll let you know in advance. You can always take the quiz early, again, because I announce it ahead of time. If you know that you're going to be gone that next class period, we can work something out. You can take it early, you can take it a little bit late, as long as you let me know in advance. At the end of the semester, I'm going to drop the 2 lowest quiz scores. Because I recognize this may not be the class you study for all the time, hard to imagine. But there's going to be some quizzes that you're just not ready for. So I'm going to go ahead and drop the lowest 2. Homework. We do them on Master in Chemistry. How many people did Master in Chemistry last semester? A good portion of you. Okay, good. The Master in Chemistry, in fact, every assignment for the entire semester has already been posted on Mastering. So if you want to be a go-getter this week and do all of it, you can. They're all up there and live. So you should know, starting today, you can look on there and see when all the homeworks are due for the rest of the semester. So you can kind of plan around your schedule. Things happen. I know sometimes you forget that you thought you finished it, but really you only did 2/3 of it. I will allow 3 assignments to be completed late with no penalty. After that 3rd assignment, though, there is going to be some penalties for turning it in late. So far? Okay. Seminars. So I'm going to assume, regardless of your major, that you all are chemists in training and that you are super excited about what is the latest and greatest in chemistry going on in the world. So this semester we're going to have 3 chemistry seminars. There's a few biology, a few animal science, and a few physics coming up also. But I really want you to attend any one seminar in the natural sciences. To get credit for going to a seminar, you need to write me a paragraph and email it to me. That's it. It doesn't have to be an explanation of what they did. It should contain, hopefully, the name of the speaker, the title of their talk, and 2 or 3 facts that you learned from their talk. Nothing tricky. Extra credit. If you attend more than one of the seminars, you can build up some extra credit. For every 2 seminars that you attend beyond the first one required, so seminars 3 and 5, I will convert your lowest test score, your lowest quiz score to a 10. So in theory, instead of dropping 2 quizzes, I would drop up to 4 quizzes. So that's the only extra credit that I can give in here. It's not bad. Let's see, tutoring. If you find that you need a tutor, the earlier you can figure that out, the better. Hopefully having a study group will help you out. But there are a bunch of tutoring options. There's the Academic Support Center, there's the Chemistry Help Room, there's one-on-one tutors. I would say the keys to doing well are going to be the following. For every hour we're in here, you should spend an hour at night going over the material. Make sure you're keeping up with the reading and come to class. The Find a Study group hopefully will figure one out together. But this class is going to be much more challenging than Chem 108. Chem 108 is often review. You've already seen it in high school. This is going to be the first class that we were going to move beyond high school chemistry into some actual chemistry. So the better you can stay on top of it, the better you're going to do. FERPA just says don't have your parents call me about your grades. I'd rather talk to you about it. If you need additional accommodations, you need to talk to the Academic Support Center. So if you find that you need more time for exams or you need something else, I can't do anything about it until you've talked to the Academic Support Center. And lastly, no cheating. Please don't cheat. I don't want kicking you guys out. So, no cheating. Alright, so then we got our schedule set out for the rest of the semester. You can see we don't cover nearly as many chapters as we did in 108. We only cover 8 chapters, but these are really big chapters. So we're going to spend this week reviewing some material that you saw in 108, in molecular forces and solution chemistry. And then spend the rest of the semester talking about kinetics, equilibrium, acid-base, redox, thermodynamics, and then a little bit of nuclear chemistry. It's all my favorite stuff. You guys are in luck. Alright, so my first job for today is going to be, we're going to fill out these snazzy note cards I got. Alright, so hopefully you've been taking a few minutes to think about these study groups. On the note card, I just want you to put the following answers. So I got note cards for you. How I deal with these very tricky questions.
You put major down twice.
I did. Man, 2 typos in one day. Okay. I only want your major on there once. Yeah, whichever place you put it, that's good. I'll give you like another minute and then I'll come back through and collect them. Yeah, so I got that typo. Yeah, I figured out the exams. Sorry, my bad. I got on exams. I'll fix that in a second.
Okay.
All right, everybody mostly answered these questions. schedule. I apparently made my schedule and then forgot to go back and change the exam dates in the text. So if you look at those dates, that doesn't even make any sense because Wednesday, February 18th doesn't exist. February 18th is definitely a Tuesday. So we're going to go with the ones in the chart. So the exams are February 3rd, March 24th, and April 21st. I try to keep it to just one mistake in my syllabus every year. I think success this year. Usually there's 2 or 3, so that's not bad. Usually I get my office hours wrong or my phone number. Alright, last bit of business before we actually get started on some lecture today. I just need to take a roll real quick just to make sure everybody in here is supposed to be in here. Alright, so I saw Ebenezer. Good. I saw Blaine. There you are. I saw Todd. Alright. Samuel Berenson. Do you go by Sam? Samuel? Sam, awesome. Megan Boswell. Good. Dina. Christopher Daniel. Good. Oh, Kyle. Yeah. Abigail Daniels. Good. Allison. I saw Allison. Oh, there you are. Zach Sutton. Elizabeth Ellis. Elizabeth. Joseph L.
How about Joey?
Joey, perfect. Caitlin Step. Ben, there you are. Kristen Penmaker, there you are. Rachel Flatt. Landon Freeman. Ashlyn Foskey. Hunter. Mallory Hammer. Hannah Hartney. Courtney Hodges. Hannah Jackson. Aaron Jenkins. There you are. Katarina. Kelsey Nolan. James Carruthers. You go by Jim? What's on Nikita? Russell. Cody's here. Winifred McLeod. Which one do you go by? Lee. Perfect. Stephanie Lasagna. Lindsay Mortimer. Sarah Osteen. Cody Queen. Nathan. Haley Smith. Hallie Smith. Haley. Okay. Paul. Laura Vanderheim. Was it close? Did I get your last name? Yeah, good. Melissa Worley. Connor. Is that everybody? Nellie Allen. Alright. Oh, that's why. I printed this off before I added you. Is that everybody else? I said your name. Yeah, no, you're good. Alright, in that case, let's do a little chapter 11 review. How many classes last semester, if you took one of me last semester, got through some of chapter 11? Some? Okay. Snare your hands. Good. I'll have to figure out how to fix the lighting because that's not right through it. Alright, so chapter 11 is looking at liquid solids and intermolecular forces within those types of compounds. So let's do a little review of intermolecular forces. Let's see if I can figure out the lights. There I go. That's a little better. Ooh, mood lighting. Still want you to stay focused. Alright, so many gases, most liquids, and many solids solids are molecular. Take a second. What's the other type of thing? If it's not a molecular compound, it's either ionic or it could be valent, right? It could be atomic, ionic, molecular, right? And those things tell you about what sort of elements are being combined, right? An ionic compound has to have charges. A molecular compound has to have covalent bonds of some sort. So we mostly are going to deal with molecular compounds. Properties of molecular substances include the following. I really like things in sets of 3. Just a fun fact. So it happens to be 3 properties of molecular substances. First, they are non-conductors. Electricity. What would, I guess compared to ionic, that's what they're looking at, right? So an ionic compound has charge, which means you can pass electrons through the compound. A molecular compound uses all covalent bonds, so it's harder to pass electricity through a molecular compound. Typically, number 2, typically, molecular compounds are not going to be soluble in water. What sort of compounds are soluble in water? Right, ionic, polar, things like that. So molecular compounds, if they're not ionic and they're not polar, what would they most likely be? Molecular / non-polar. So if they're non-polar, do they have or have not a dipole moment? They don't typically have a dipole moment, right? There's no pull in any one direction. Is water a polar or non-polar compound? Polar. What sort of solvent then would I need to dissolve my molecular compound? Non-polar again. Just warm you guys up, trying to get those cobwebs gone. Alright, the last thing is that they typically all have a low melting and a low boiling point. If they have a low melting point, so melting, right, is going solid to liquid state, right, and then boiling is going liquid to gas state. If you have a low melting and or low boiling point, are those bonds between molecules weak or strong? Right, they should be weak, because it's not taking very much energy to force them into the next state of matter. All 3 of these, more obviously this third one, reflects the fact that the forces between molecules in a molecular compound, which is what we're going to call intermolecular forces, are weak. Good so far in that review? All sounds vaguely familiar, polar, non-polar, okay. So let's look at specifically some intermolecular forces. So a type of intermolecular force will be dispersion forces. Depending on what textbook you're using, sometimes they're called dispersion forces, sometimes they're called London forces, sometimes they're called van der Waals forces. It's all the same sort of interaction going on. So, we just said that molecular compounds are typically nonpolar, which means that they don't have a dipole moment, but they do have induced dipoles. So a dipole is when it always has a kind of positive and negative end. An induced dipole means it doesn't always have that positive and negative end. It can be forced to have a positive and negative end. For example, let's take a look at, let's do, my little dots are hard to see. Let's look at nitrogen gas. Would you be able to draw this as a dipole? Does it have a obvious positive and negative end? It doesn't, right? Because you have two of the same atom, which means their electronegativities are the same, which means its overall moment is zero, right? There is no positive negative end. But we can imagine that sometimes some of the electrons end up over here, and we end up right, that is a possible Lewis dot structure. Pretty terrible. Right, so that would be not very often it would look like that. But there is the probability, slim, that it could look like that. So when it looks like that, now I have an induced dipole. Right, I have this and this. That if it came into contact with another nitrogen, it could force it to be the opposite. So now I have these two. This one started off, it forced the one next to it to become the opposite, and now there's an attraction between the two molecular compounds. This right here is the dispersion force. That there's a momentary instant where you have two molecules that are not normally polar become instantaneously polar, force another one to become instantaneously polar, and there's a mini attraction just for nanoseconds. So the strength of a dispersion force, like we're seeing here, depends on two main factors. So I'm going to use the symbol a lot. It doesn't mean hashtag. It means number of. Man, that'd be a really long hashtag. So number of electrons in the atoms in the given molecule. So here, right, nitrogen each has 5, so overall there's only 10 electrons in a molecule of nitrogen. We imagine a much larger, like you think a noble gas, maybe like xenon, right? There's a lot more electrons in in there that could be, see, that's a terrible example, it's a noble gas. Bromine, we'll do bromine. Bromine, right, much larger molecule when it's Br2, so it'd be in theory easier to force 2 electrons onto the opposite Br from the other one, because they have a much larger electron cloud. So the number of electrons in the atom in the molecule will make it easier to have an induced dipole. And the second part, which is kind of directly related, is the ease with which electrons can be moved from one atom to another. So just like in bromine, right, there's a lot more open valences that you could put those electrons into. And so the larger the atom, the easier it is to make an induced dipole.
You say then the greater amount of electrons that the atom has, the easier it is.
Yes. Yep.
Okay.
There you go. So both these factors increase with molecular size. Right, larger molecules have more atoms. More atoms means more electrons available. So that more electrons available means it's easier to disperse just 2 from one side to the other. How do you feel about dispersion forces? Fairly confident? Questions on this so far? Starting off with some little bit of review. Alright. In that case, let's take a look at my fancy figure. It came out of your textbook, don't be impressed, I didn't actually draw it. It is 2 ovals, where one side is darker than the other. Right, so the dark side minus, when it comes near another atom, it forces it to have an induced dipole, so now it has a negative and positive side. Pretty graphically amazing, right? Super impressive. And the other part is this molar mass on boiling points. So, right, we have noble gases that as they get larger, the boiling point decreases, which is because they're technically atomic, right? You can't really have an induced dipole in an atom. But then if we look at, like this one I was just talking about, bromine, if we look at the difference between fluoride gas and bromine gas, the boiling point increases because it's easier to make a dipole moment, which means it takes a little bit less energy to force it to go from one stage to the other. Good. Alright. Let's talk about dipole forces. So, dipole forces is another intermolecular force. However, in this case, the molecules participating in it must have a permanent dipole moment. So they are not ionic, but they have to have a permanent dipole moment. So just because it is having a permanent dipole moment means it not only has a dipole force, but it also has dispersion forces. So everybody has dispersion forces, but you may get an extra intermolecular force depending on what type of molecule you are. So, in this case, my fancy figure over here, I'm using, it's hard to see in your picture. NaCl. Oh, that's not, that'd be ionic. Let's do ICl. So iodine chloride. In this case, right, chloride is closer to the top of the periodic table than iodine, which means it has a larger electronegativity than iodine would have. So it would have a permanent dipole of
sort. So we're seeing here that dipole forces would force a set of these molecules to line up like this. Right, so I am forcing it into a regular structure. Alright, so this is just in 2 dimensions. If I expand this out into the 3rd dimension, it starts becoming kind of cubic. Right, because you can imagine every iodine is near a chlorine, and every chlorine is near another iodine, and there's alternate magnetic poles. So what would you imagine the melting point and boiling point? Would they be higher or lower than a molecule that's just dispersion? They should be higher, right? So melting and boiling points of compounds that have